Hello and welcome again to CHeM in 3. Today we take a more in-depth look at a specific area related to rate, order and molecularity. Looking specifically at this rate law or this rate expression for this reaction. Looking at this rate law, it's easy to believe that the rate law can be established from the equation, because you can see that the concentration of NO is squared, and here you see 2 moles of NO, and then you see that is multiplied by the concentration of O2, and here you can see O2. So you might be led to believe that from the equation you can derive the rate expression or the rate law. And of course, the rate expression can only be established from experimental evidence. And while it is true that this equation as given does suggest that this is a possible rate expression, this does not give any information about the steps involved in this particular reaction. And here you can see the actual steps involved in the reaction, where there's a fast step and there's the significant and slow rate determining step. It is this second step here that really determines the rate. But N2O2 is not a reactant, nor is it a product. So therefore it cannot be a part of the rate expression. N2O2 though is responsible for the rate determining slow step. It's one of the 2 molecular entities that create this bimolecular second step of the reaction. But N2O2 is derived from these reactants. So these reactants here go into the rate expression and they're multiplied by this. So these 2 starting entities which give rise to this N2O2, which is really a part of the slow rate determining step, these are the 2 that go in here. And this O2 actually belongs to the second step, the slow step. And these 2 are actually giving rise to this, which is a part of the second step. But because it's neither a reactant nor a product, it cannot form a part of the rate expression. So this is how you would then write the rate law or the rate expression once you have figured out all of the steps in a reaction. And it is from this that you can go to this. Now I would like you to take a look at this question and to decide which of these mechanisms is not consistent with this rate expression, which is the same rate expression that we looked at previously. Then which of these 4 would not possibly give rise to this? Stop here, review the explanation, think about it, and then decide which of these 4 is not consistent with the rate expression. If you decided that C is not consistent, then you're correct, because if C were the rate expression, then the fast stage of the reaction, which produces NO2, is not even a reactant in the slow step. So the fast step does not lead into the slow step like it does here and here, where the product of the fast step leads into the slow step, and here the product of the fast step leads into the slow step. But only the reactants of that fast step go into the expression. And here too, only the reactants of that fast step would go into the expression, with the NO being one of the reactants and the O2 being one of the reactants that can give rise to NO squared, meaning that this is a valid choice. But it's only C that doesn't in any way match the given rate law. So the answer to this question is C.